Welcome students to another episode of SB Maths class. We have completed the congruence of triangles, that part. We have described in details and also done some of the sums. Today we are going to start the quadrilaterals. Actually in your syllabus here quadrilaterals in this quadrilateral chapter it has been emphasized only on the parallelograms, and some of the triangles and parallelograms, some relations are there, that is the area of the parallelograms and the triangles at that chapter. So here we will only discuss about the results, the properties of the parallelograms, the related theorems, and also some of the applications. And also you know about that is we'll do here only the most important theorems what comes at your exams, and also obviously those have great impact on the other chapters, that is those results are very much important. We will do only those. Your work is to practice all of the results and all of the theorems, extras, whatever it is given at your book. So students, let's get started. Theorem we are going to do is this, that is, if ABCD is a quadrilateral whose diagonals AC and BD intersect at O, prove that, then those two results are there. You have to prove those. So actually here I have drawn a trapezium, because here the quadrilateral, nothing special it is given, it is said only the quadrilateral. I have told you that is, if the triangle is given, that is no any proper names are given, that is isosceles or right triangle or equilateral, and this type of specific names are not given, then you have to draw the scaling triangle. Here also, if the quadrilateral known as proper names, that is rhombus or parallelogram or this type of names are not given, then try to draw the trapezium and also this type of trapezium. Okay, so here this is one quadrilateral where ABCD are the vertices and the diagonals AC and BD are intersecting at the point O. We have to prove those. So for the first one, directly I am going to prove. Proof number 1. We will use one property of the triangle here, that is, you know, that is the well known property, that is sum of the two sides is greater than the third side. It is the property, simple one, basic property of the triangle. So here for triangle ABC, AB plus BC is greater than AC. Actually inequality was not there in your syllabus, that's why I have skipped that one, but actually simple properties was there, like that. Here you can write, that is sum of two sides of a triangle is greater than the third side. So here you have to choose the triangles in such a way, that is, just see here we have taken ABC, that is AC is one side there, again we have taken ACD, AC is another side there, that is you have to take the triangles in such a way, that is AC and BD will be the common sides there. Two triangles with the sides AC and two triangles with the sides BD. Okay, and also the AC and BD will be at the right hand side. In such a way you have to also arrange those inequalities. We can arrange this one, AB plus AC is greater than BC, it is also right. We can arrange this one, AD plus AC is greater than CD, but our aim is to keep the AC and BD, those two sides at the right hand side of the inequality, because we have to prove that one. At the question only, at the right hand side AC and BD is there, so we have to keep AC and BD at the right hand side of the inequality. In such a way you have to arrange this one. Now just adding the inequalities. We are getting, just see, 2 times AB is there, 2 times BC, 2 times AD and 2 times CD. So 2 into AB plus BC plus CD plus DA, or you can write AD, is greater than, here 2 times AC and 2 times BD. So 2 times AC plus BD. So here 2 and 2 will be cancelled out, and finally we will get the number 1 proof what it is required for us, that is this one, proof number 1. Okay, now just pause the video and also jot it down. I will erase the board and we will do the proof number 2. So students, we have done the proof number 1. Now proof number 2. Here also we will use the same property of the triangle, that is the sum of the two sides is greater than the third side, but the arrangement will be the different. There we have taken the triangles. We have taken the triangles as ABC or ACD, that is the total one with the sides, common sides AC and BD. Here what we will take? Here actually we will take AOB, BOC, COD and DOA, that is those triangles AOB, BOC, COD and DOA. 4 triangles are same. Here we will take those triangles only. So from triangle AOB, and also you have to keep in mind, that is all the main sides, that is AB, BC, CD and DA, those will be at the right hand side. You have to arrange in such a way. So from triangle AOB, AO plus OB is greater than AB. This is the AOB triangle. So AO plus OB is greater than AB. I have told that keep the main sides. Those sides are the main sides of the quadrilateral. So keep those at the right hand side, because we have to take this one at the right hand side. Here just see the sign has been changed. So this will be at the left hand side, this will be at the right hand side now. Okay. Now form triangle BOC. So BC will be at the right hand side. So obviously BO plus OC. Here triangle COD. So here CD will be at the right hand side. So here CO plus OD, and triangle AOD. AO plus OD is greater than AD. We have got this one. Similar logic you will write. I am not writing here. Okay. Now adding again. Adding the inequalities. So add all of these. So just see, here also 2 times AO, 2 times OB, 2 times OC and 2 times OD is there. So 2 times AO plus OB plus OC plus OD. You can take at OA also. Just it's looking like better. Okay. And also it is greater than, here AB plus BC plus CD plus DA. Now OA plus OC, just see OA, that means AO from here OC, AO and OC, it makes AC. So 2 times AC plus here OB and OD. So OB and OD, it makes the total BD. So AC plus BD is greater than AB plus BC plus CD plus DA. So it's the proof only. Just see, this was actually it is written at the reverse way. You can put like that. So it's the proof only. So students, first of all pen this one, this result, and also for the quadrilaterals one of the most important theorem is this one, and also this property. So just you have to practice this properly to do the sums, to apply this. Okay, so students, today up to this we will do the next theorems and next results at the next videos. So stay tuned for this. Thank you students.